played hide and seek for hours, raised our shadows among the pines. So offshore, playful and free, without a care in the world. I was one rich little girl, daydreamer, kidnap me, take me back, all the way back to them days, running around in a gown and a crown, barefoot. No mistake ever kept me late. We spent summers catching fireflies and winters on our skates. One big smile across my face. We used to dance our way to church on Sundays. Mama set the pace. Daydreamer, kidnap me, take me back, all the way back to them days, running around in a gown and a crown, barefoot.
And that, my friends, is what we saw this weekend. Nashville, the Twin Cessna Pilots Convention. And we went out there for that and met some people and sold a few of the books and did a talk. Talked about weather forecasting and especially radar. A lot of people interested in that now. Anyway, we're here back today, and you can see a few tropical thunderstorms off to the east here. Kind of spectacular there. And there's a look out to the west, and this was all taken about 30 minutes ago. So welcome back to the webcast. It definitely has been a while. I think about 3 days there, and it's been kind of difficult streaming on the road there. But anyway, back to normal, and there's our maps again. So we've cleared out a lot of the tropical moisture, and it's all along the Gulf Coast and out in the southeast. Little sliver of it extending up into Texas, but basically anywhere that you see the white or light beige colors, that's going to indicate dew points in the 50s. And then as we get into the green, dew points in the 60s and 70s. So we just don't have very much moisture to work with in much of the eastern U.S. and a similar situation out in the western states. There is a strong front. It's kind of, I guess it's kind of stationary right now, and we're going to see some big changes coming out that way later this week. Let's take a closer look. Look down at Texas here, and there we see that moisture axis there, a few 70s hanging on, anywhere from about Lufkin up to Greenville, down to Corsicana, Waco, and down to about LaGrange. And you can see the easterly component. The flow is doing something like that. So the origin of this air is from the Midwest. The true tropical southerly flow, we have to go all the way down to the western Gulf Coast to find that. There it is. And we had thunderstorms in the Houston and Woodlands area last night, and those moved southwest. I should say west-southwest towards the Austin area. Went through there about 2 or 3 in the morning, and then the area kind of broke up, and there's another MCS that got going and moved east. So you can see this flow is kind of anticyclonic, indicative of an upper level high in the region. The remains of that outflow are still lying down to the south there in the Interstate 10 corridor, and you can see there a little baroclinic low, maybe a hybrid of a thermal low and baroclinic low. That's going to be around Sanderson. Temperature is very warm there, 100 degrees, Eagle Pass 99 at Del Rio, 98 at Sanderson. That's pretty toasty, and of course if you go into Mexico, it's not too hard to find even warmer air. Trying to find some scroll bars here, and yeah, there we go. 104 at I think that's Ciudad Victoria. Some very warm weather. Let's go up north. I don't think we have too many viewers in Mexico. If we did, I might cover a little bit of that area. So we're going to go up north to Kansas, Nebraska, and Colorado, and there you can see the dew points are kind of depressed in that area. Lots of 50s dew points, and let's go out to the Midwest. Can't go too far on this projection here, can only get about as far as western Indiana. And you can see that there is not much of a tropical feed of moisture. Most of the flow is very light from the southwest. The stronger flow is up in Iowa and the Dakotas. And you can see the dew points are on the low side. Let's head to the charts. And I think a good place to start will be SPC. Only marginal areas, one area out in Montana, another forecast out in North Texas, and there have been some big storms going on in Florida. And I'm going to show you that on the satellite imagery. Let me see what this mesoscale discussion is. This is for East Texas. We're looking at some weather developments in that area, probably related to that thunderstorm that I saw earlier on that drone footage. Storm reports, looks pretty light. This is par for the course for spring 2018. And we should tally up the tornadoes and see how those look. I don't know, has SPC done that? I don't know, but this definitely has been kind of a disappointing spring as far as storms. Let's start out with 250 millibars, and this will give us some idea of the steering flow and the general setup of the thermal pattern. Polar front jet well up to the north. That's all the way up into the Canadian prairies and running across the Great Lakes and then out towards the Canadian Maritimes. The southern regions are showing that some of the anticyclonic flow has abated a little bit, and we're seeing westerlies just about everywhere. So you see that right there. The only area where the flow is kind of light and variable is out over that area south of Del Rio. So it looks like that front coming through has kind of helped bring the flow around to the west. Looks like maybe a bit of subtropical jet action right in this area. I'm not too sure. That could be a polar front, maybe associated with that little outbreak of cold air. If you're not sure, good trick is to go down to 500 millibars. And this is what it looked like this morning, and you can see the flow in this area. Well, that's 20 to 30 knots there. That's fairly healthy. So I would probably classify that as a polar front jet. Do we have subtropical jet action? I don't really think so. So just kind of a broad westerly flow across the U.S. 700 millibar chart. This gives us information on the cap strength, and it has been eroded, largely due to that cold air and the northwesterly flow that we had. When you have northwesterly flow in the Great Plains, that tends to advect a lot of that warm capping air to the southeast. When the flow is not out of the northwest, Get that air heating up in the desert southwest, and it'll tend to drift out onto the plains like that. So when we have that northwesterly flow, that kind of clears that out. And not surprisingly, removing that cap, that can get thunderstorms going, and that'll give us those northwest flow thunderstorms. It's kind of common in late spring and sometimes very early fall. We'll get those northwesterly flow storms going in this area here. 850 millibar chart showing the moisture. Highest readings I'm seeing here is 16 at Fort Worth. It's going to be about a 61 degree dew point. Remember, this is all up at about 5,000 feet MSL. And very weak southerly flow coming up from the south. The general flow across the Great Plains is painting out a high right there around the Springfield, Missouri area. So you can see the flow coming around. Kind of anticyclonic like that. And anything else to look at? I think that's probably it. Very strong trough out there in the eastern U.S., there in New York. And you can see that thermal gradient right offshore. So based on that, I would probably put an 850 millibar front. Kind of like that right there. Yeah, look at that gradient right there. That's pretty stout there. 15 Celsius. That's about 60 Fahrenheit all the way down to 50 Fahrenheit. That's pretty good difference for that level. 1,000 through 500 millibar thickness. This is kind of like the master key to the thermal structure of the atmosphere. Of course, 300 millibars gives you one tool for looking at that, since everything at 300 millibars is dependent on the density beneath it. So, you know, that can give us information about the thermal structure, and this kind of verifies that. And also gives us information on the fronts. Most active area this evening is in Saskatchewan. And there we see a frontal system moving through that area centered around Saskatoon. Warm front through North Dakota, all the way down to Minnesota. And then southwest from that baroclinic system across Montana down to Idaho and northern Nevada. A little Pacific front coming through that area. And that's being driven by this 1028 millibar high way offshore. And as we get into July, we see more and more of these strong high pressure areas. This is kind of a semi-permanent high, and when we get into July, we're going to see it covering much of this area. It's a very cool high, and that tends to drive the marine layer inland. Oftentimes on the coast in the summer, you'll get fog coming inland. And it's enhanced somewhat because the air out here in the Pacific, very cool. In inland, we get the very strong heating, especially when we get the thermal low developing in California, Nevada, and Arizona, right in that area. So the pressure gradient sets up between the dense high pressure high and the hot low pressure area inland. So you get this component right there, bringing winds inland, and sometimes we'll see that fog sneak inland all the way through the San Francisco Bay Area inland and into the LA Basin. And it can be kind of problematic to clear that out during the day. So if you're flying into LAX or San Francisco early in the morning, that fog can be a problem in the summer. Let's take a look at the NAM, see what's going on. And for that, I'm going to switch off to Texas. Let's find out where that is. And this will get me all caught up. I haven't really looked at much weather information. There's been a lot to do since I've gotten back. And so, yeah, we're getting up to speed here. And you can see that the warmer air is down to the south. And that definitely verifies the position of that front down there in the Interstate 10 area. Out to the west, downslope flow helping to heat things up in that area. And up in Colorado, looks like a bit of a lee side trough, thermal trough, lee side trough. Looking at that, let's see, what is it, 92, 91, yeah, it's pretty warm there. I'm looking at over here at Pueblo, La Junta, very warm temperatures. So I'm not really too sure which one that is. Let's look at the upper air flow. And I don't know, I'd really want to see more wind. 30 knots, that's kind of modest right there, and 10 knots at 500 millimeters. Okay, we're going to call that a thermal low. So there you go. You can see how we put some of the forecast together. So let's bring that back up. Back down to the Texas area where we've had thunderstorms down there in the Houston area last night. And let's see, what do we got going? Developing out around the Palestine area this afternoon. You can see it's got some thunderstorms going up, and you can see the outflow pools spreading out there across East Texas overnight. So maybe that's what they were forecasting for their SPC. And then, see this really congested area up there in North Texas. This is around 5 a.m. Looks like the NAM is trying to develop some thunderstorms in that area. And you may be wondering why. There's another chart that I'll be showing you shortly. And it looks like some thunderstorms also get going in Louisiana. See right here? What I'm looking for is these circular noisy spots like you see right in here, like I'm outlining. When I see those on the chart, it indicates to me that the model is developing cold pools. Those are areas of enhanced pressure due to the cold air coming down, and as that develops further, you can see the thermal field start to show a lot of yellows as that cool air comes down to the surface. So by dawn, looks like a bit of a cold pool across Louisiana into East Texas there, and that could set the stage for a frontal boundary, or not a outflow boundary tomorrow. And I'd be looking for that maybe in this area right there. So that could be a focus for thunderstorms later. Also around the College Station area, maybe one there too. So yeah, we're kind of hitting Texas pretty hard here. I know not everybody is from Texas, but what I'm trying to do with this webcast is not necessarily give you the news and area by area, because that would run 2 hours and people would get bored. What I'm trying to do is impart some information that you can use yourself. So the same principles apply. The physics of the atmosphere is pretty much the same. The main differences you're looking at are, of course, land and sea, and orography, and to a certain extent latitude. Okay, let's see, for tomorrow, where are we at here? This is late afternoon. Very hot temperatures there in West Texas, lots of hundreds in that region, and you can see some thunderstorms going up there in the higher elevations. It's probably a, I don't know, I'm not sure if that's going to be a dry line or just convergence in that area where the heat lows are developing in those hot temperatures, but you can see that cold pool really shows up there about 8 to 9 o'clock. That's when we're going to be doing the webcast, so we might get a look at this tomorrow. A bit of a thunderstorm system across the Childress and Vernon area at that time, and that'll be surging down the Red River towards Wichita Falls and probably dying out. Continued easterly flow through midweek. You can see the source of that air right there coming in from the Midwest region, and look at that convergence right in this area here. So that's where the tropical air is coming onshore and meeting up with that air up there in Arkansas and Louisiana. So that would indicate to me probably a zone where a front is located. So Wednesday, frontal boundary across Texas from about Lufkin up to Childress. And then just running through the rest of the frames here. Another hot day for West Texas, and more influence there from the Midwest region. And what the main thing that you'll see here is the strong temperature difference. See out here in the Fort Smith area, lots of 88 to 89 degree readings, and then you go all the way out to Altus and Childress, Elk City, 100 degrees. So very likely we've got a frontal boundary right through that area. That's probably that same front lifting north. And you can see the temperatures coming up on the south side of that in Dallas, Waco, Austin, all up near 100 degrees. So anywhere south of that frontal boundary on Wednesday, it is going to be hot. San Antonio, San Angelo, and especially Midland, model going for 106 in that area. We can take a quick look elsewhere. Let's. I know we got a lot of viewers up in the Midwest, so let me switch over to that. I'll just give you a quick run through here. Let me bring down the time and forecast hour. So we start out with high pressure there in Missouri. That's very identifiable due to the anticyclonic flow You know, guys, I really need to look at the chat, make sure the feed is not having Oh, geez, 1932 drop frames. That might have been on the opening intro. I know that was probably very busy video-wise. So let me just see what's going on here. I'm looking at the chat. There you go. You guys can look at me, look at chat. Okay, Electric Dog, 80 degrees up there in northern Illinois. Ron Chalfant, 80 degrees, mostly clear, light winds in Southern California. Alexi, 82, and cloudy in Texarkana. And Erica Baker, happy I'm back. Thank you for that. 82, 58 degree dew point. So that dew point has really come down there in Kansas. Carl Berghoff is with us. Let me give you guys the satellite. That's kind of traditional here. There you go. We'll add some motion there and maybe get a little bit of buffering. Hopefully not, but I don't know. I'm going to watch for that. So, yeah, there it is. You can see that little wave moving across Texas and Oklahoma. That's what produced the showers and thunderstorms in that area. And then up to the north, where that frontal boundary is, up in Saskatchewan and Montana. Some good storms going up in that area. Okay. Yeah, we forgot to do the camera. Okay, hey guys, and let me switch over and get caught up on the rest of the chat real quick. Shirley Keast, 57 and sunny in Michigan. Ryan Toomey's down there in Florida. Welcome to chat and the webcast. Sue M, 70 degrees, southern Indiana. Horse sit last week. Yeah, horse sitting, we've done a bit of that ourselves. David Holcomb, hello there. And Ryan Toomey said felt like 105 degrees there in southern Florida. Fun with Tech and Electric Dog, Burl H, 81 in Iowa. Willie Greenway there in Georgia joining us. Patrick Motes out there in southeast Tennessee. Yeah, I wasn't too far from you a couple days ago. Only a Texas 10-minute delay. Thanks, Ryan, there. David Moore likes the intro. Bill K. out there in Atlantic City, 72 and clear. Yeah, Ryan asking about the road trip. Yeah, that was kind of a nice break, and I definitely enjoy going out east because, you know, usually when we head somewhere, it's San Antonio, Houston, Oklahoma, stuff like that. Going east is actually kind of exotic, and especially getting east of Little Rock. Memphis was pretty cool and not much traffic, very beautiful out in that area. And Nashville, man, the magnolias were just really something else. Yeah, a couple of things here. Patreon donors, I don't know if I've showed you this, but let me bring that up here. Let me know if you guys have seen this. If you haven't, I apologize. But I wanted to thank the new Patreon donors. And that includes Michael Davidson and Edward Davies. Trent Tubazuski, I appreciate the donation. CDMA 531. Greg Kerner. Joseph Nixon. Michelle Curlin. And Clyde Hoadley. Thank you very much for supporting the channel. Those donations are very important, and that's what keeps me coming here day in and day out. It does get to be kind of a grind doing this, and have to set aside about 2 hours to put the show together. And for those donations, I do appreciate that. And I do need to let you know that we are going to start doing something special for the Patreon donors, and we're still trying to work that out, and I think that'll be announced on Friday. So if you're getting something out of the channel and you haven't donated yet, that is very much appreciated, and there's where to send the donations. And you know, especially you know, every little bit helps, you know, even if it's just $1. If you can send 20 or 30, that's great too. That's helping to, I don't know, I've already gone over that. Checking my notes. Okay. Yeah, so there it is. Patreon.com/MetLab. So going into the satellite, not a whole lot to look at. You can see the northerly flow across the Great Lakes area. Very wound up storm system there in Quebec and Ontario. And down there in Florida, getting some storms. Let me pull up that sector. Yeah, it's definitely nighttime there in Florida. Let's run that back. And what you can see here earlier in the day, little thunderstorm cluster around the Titusville area and inland around Lake Okeechobee, a little boundary. It looks to me that, let's see, what do they got? Westerly flow in that area. Let me run this forward. Yeah, pretty strong westerly flow. And this is probably a bit of a sea breeze, maybe coming from the Fort Myers area. And let's run this forward and watch this storm cluster up to the north. You can see that moves through the Vero Beach area. Look at that cold pool. It is really moving south and cranking, and you see new thunderstorm development along that boundary. I don't know if that's reached Fort Lauderdale and Miami yet, but I would think that maybe some of the outflow would maybe get to the northern periphery of that area. Also, Montana has been getting some thunderstorm activity. Let's see how that looks. Run that back. Look at those transverse bands, those ripples out there in Montana. These clouds up here are at about 20,000 to 25,000 feet. So that's in the 500 to 300 millibar range. So a very strong jet stream across that area. And then down at the surface, of course, we've got a frontal system running through that area. So a lot of ingredients helping to produce lift. And of course, the thermal profile of the atmosphere is supportive for thunderstorms with the cold air aloft just to the west. And we'll run that forward and see what happened. Thunderstorms going up on the plains right there, east of Great Falls and Helena. I don't know all the towns out in this area. I guess Miles City, Glasgow. And those are continuing to move eastward. And let's see what else we got. I think one more. Yeah, Mexico. We got anybody watching the show from Mexico? Storms there in the higher terrain right there. That's the Sierra Madre West. Let's see, Occidental. You can see those fire and lots of anvils, and those are dumping a lot of anvil debris out into the Rio Grande area of Texas. So maybe kind of a cloudy night there in Del Rio. And that's kind of significant because temperature is very hot, still probably in the 90s at this hour. Then you send all this overcast over them. Any guesses what happens? Very hot temperatures down there, and then you send the cloud blanket over at night. That's going to block the long wave radiation from going up into space. And what happens is during the day, you've got shortwave radiation coming down to the ground that heats things up very quickly, and then at night you radiate the heat away as long wave infrared radiation. So clouds are pretty good at attenuating that, and as a result, we're probably going to have kind of a hot night in that area tonight, maybe lows near 80, I would think. Okay. Elsewhere, yeah, I've got a water vapor image. And there really, that really shows that wave there in Arkansas and Missouri. Let's run that back. That's how it looked about 2 hours ago. Lots of dry air aloft there in the Texas Panhandles region. I'm going to check out maybe the Amarillo sounding. We'll see what's going on there. And then you can see those anvils out there coming into West Texas. Out to the northwest, baroclinic action out in that area, and you can see kind of an S shape to that moisture profile. So it looks like our next wave is coming inland, and what we're looking for is kind of a shape like that right there. We don't quite have that. We've got kind of a backwards S going on, so that's going to be associated with some downward motion. So the next wave probably coming in tonight, and we'll see where that ends up. We'll check out the model data. Then, of course, we have the new low-level water vapor product from the NUGOS satellites. And I haven't looked at this too much, but I am keeping an eye on it because that could really help us out when we have clear skies and we're trying to find out where storms might be later during the day. these orange colors might tell us where the richest and deepest moisture would be. So this is sensitive to the lower part of the atmosphere down below 15,000 feet. But the problem is you can't observe it through this cloud material. It only works like where I've got the red right here. So anyway, that's what's going on tonight. Okay, let me go back through the products, see if I missed anything. There's always a lot to keep up on. I don't know if you guys have looked at this SPC experimental site. Let me bring that down. spc.noaa.gov, EXPER. I really like this sound in climatology. I've been meaning to show this to you guys, but you can pick any site. And I know we've got a lot of viewers in the Midwest, so I'm going to pick Lincoln, Central Illinois. Yeah, let me zoom out on this. Okay, get that centered. Zoom that out a little bit more. So what are we looking at? We're looking at a calendar from January through the end of December. And this is showing us precipitable water on the left right there. So this is basically all of the moisture, all of the water vapor that's in the atmosphere above Lincoln, Illinois. And what we're seeing here is climatological normals. So typically during the winter, we're looking at about maybe just under half an inch of precipitable water. And then that's going to peak in late July. And we see about an inch and a quarter at that time. So this is a great site for seeing what values you might be expecting on the charts, and CAPE is a great one. Mixed layer CAPE. This will show you the normals and the extremes. And wow, look at that. We've had CAPE up to about 5,500 there at Lincoln, Illinois. So typically CAPE runs about below 500 to 600 joules per kilogram. And let me pick out one more. There's so many fields that they've got in here. Yeah, look at this over here. These guys at SPC, they do some amazing work with all these little applets, or I don't know what you want to call these, modules. I mean, so much stuff. And I want to look at just one more. Let's try at 50 millibar dew point. That's always interesting. So there in Lincoln, especially in the summer, they're going to get a lot of moisture from evapotranspiration. So you can see right there, 850 millibar dew points running just under 50 degrees Fahrenheit, 10 Celsius. And the records go all the way up to 16, 17 degrees. That's going to be in the low 60s. And then we'll just check out very quickly Corpus Christi. And there's the normals, very moist conditions all the way from May through September. And they typically run this time of year about 48 degrees, about 9 degrees Celsius. All right, and let's go ahead and look at some soundings right now. I know a lot of people request that. Seems like a lot of people are weak in soundings, and they're always trying to learn a little bit more. Here's the Fort Worth sounding for tonight. Let's zoom that out just a little bit. Yeah, we got 720 streaming here, so hopefully you guys can see a little bit more detail. Got a lot of moisture there at Fort Worth. Tropical air all the way up to about 750 millibars. That's going to be about 9,000 feet. And you may be wondering, how am I getting 9,000 feet? Well, I've got most of these values here memorized. You don't have to do too much memorization in meteorology, but one thing that will always help you out is memorizing these millibar values and knowing what the conversion is to feet. So 500 millibars, that's going to be up about 18,000 feet. 700 is about 10,000. And 1,000 is very close to sea level. It's all really easy, and all it takes is a little bit of practice, and you'll get this down quite well. So above 18,000 feet, we've got a lot of dry air in that area. So that's what we were seeing there on the water vapor imagery. If I can find it. Yeah, there it is. Yeah, see all that dry air in that area? That's exactly what we're seeing on that sounding. So the satellite and the radiosonde data do check out. So we'll also look at Amarillo. They should be showing some dry air at that level. No observation. We'll see if they've got a 12Z from this morning. And a little bit of dry air, but they've had a little bit of cirrus layer this morning. All right, so let's see. What does that bring us into? Yeah, let me do a couple more soundings. This is always kind of fun. Let's look at some really weird, exotic locations. What are we going to do? Let's see. Let's go up to the Arctic. It's not a whole lot of sounding data, but there's a few in Greenland. There's Eureka, Cambridge Bay, some in Alaska, and even in Russia, quite a bit of soundings. So even though Russia and the U.S. are not great friends, they do provide us with very valuable data, and of course that's much appreciated. Franz Joseph Islands right there, and up in the northern periphery. Let's look at this one right here. That should be interesting. Got to get the skew-t. So we're looking at Russia in the very high Arctic near Nagurskoye, up in that area. And there's the sounding for that area. So it's actually a fairly mild profile. See this temperature line? And you may be familiar with that trick that I use when I take temperatures in the mid-levels and I bring those down kind of between the dry and moist adiabatic lapse rates. So what I'm talking about is between that line and this line right here. So I bring that down, and you can see that we see temperatures around 10 to 15 Celsius. That's very warm. So this looks like we've got a layer of very warm air from maybe a more southerly source region, and below that some very cold air near the surface. Looks like a frontal inversion. See that right there? Both the moisture and the temperature, both of them are going up and to the right. So we're seeing very high humidity air becoming warmer with height. And that appears to top out at about 5,000 feet. Okay, let's try one more. Let's try one in Africa. So we're doing sounding practice in Africa, or around the world. It'd be kind of fun to do like an African meteorology lab and just, kind of cover the weather in just one continent. We'll have to do that sometime when things get really slow. Okay, well, what do we got? We got lots of stations in South Africa. We got a few in, I'm trying to remember the names of these countries, Guinea, I think, and there's nothing in Nigeria, nothing along the coast there, a few in Algeria, Morocco, and one in Cairo. And look at that, nothing in Eastern Africa. It's a wonder that the models even work. I mean, they do give us output for that area. I mean, how are they filling in all this area? I mean, this is like thousands of miles. Well, they've got a very powerful analysis program, the Global Data Assimilation System. They've got a specialized team that fills in the data wherever they can, and man, those guys do a good job. I'm thinking about, if we ever make a trip to Washington, D.C., I'm going to try to hook up with them and get some video to share with you guys. So, yeah, let's go into the heart of Africa, maybe in this area, FKKN. What's their skew-t look like? Whoop. Skew-t. Yeah, there we go. Well, you can see quality problems are an issue. They're only given the mandatory levels, 700, 500, 300. And you may wonder, why is that? Are their radiosonde equipment bad? Well, no. The problem is that in these remote, I guess you want to say third world countries, they don't have a whole lot of computer technology and networks to transmit this information, and quite commonly the observer has to launch the balloon, kind of do everything by hand, and they get on the phone and they call the teletype facility, and that could be hundreds of miles away with very poor telephone connections, and they list out all of the information by hand or by voice. Let me show you what the data looks like. So this is what they had to transmit. So there's some poor observer that was getting on the phone, and that's typically what happens, and they have to recite all this information over the phone to somebody on the other end, so you can get errors and stuff like that. So you can tell that's going to take quite a long time. That's going to probably be about a good 10 or 15 minutes. Let me show you what it looks like for the US. Okay, so there's TTAA. That's about how long it looks for Africa there. Let's go over to the US and see what our observations look like. It's a little different. There's Norman. Much more data. So yeah, when they're kind of limited on equipment, they have to kind of cut corners, and that's what happens there. Okay, so that brings us to the next feature. Okay, guys, for the forecast, we'll look at the high resolution rapid refresh. This is what it looks like this evening. And I have not verified this model data. Maybe this is a good time to show you how to verify it. So to do that, we go to our, let's see here. We go to our weather products, and we find a good radar image. Okay, so here's what the radar data looks like for East Texas at this time. East Texas, Oklahoma, and you can see looks like the main convective elements in the Longview area down to Lufkin, and then looks like a little bit more elevated stuff in the Texarkana region. And this is probably wind farms, ground clutter from that. And let's see the high resolution rapid refresh. Did that verify? Kind of, yeah. Definitely got the main hot convective elements and the elevated stuff. A little bit of positioning error, maybe not as far north with that. So that's one thing you have to kind of do, make sure that things are feeding into the model correctly. And the general trend is for those to move southeast through Louisiana during the midnight to 1 a.m. hours. And then look up in Oklahoma right here. This is around Pauls Valley and Purcell, and we get thunderstorms get going in that area. Ardmore all the way down to Gainesville, and this is up around 7 a.m. Pretty good area of thunderstorms there around Sherman, Lake Texoma, and they actually increase in extent all the way to 14Z. So what's going on there? I mean, after 3 to 4 a.m. we should see thunderstorm activity start to die down. That's kind of what happens. But these things, let me run that back. Okay. This is 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m., 7 a.m., 8 a.m. So they're increasing in coverage. Okay, so when you see this, you have to keep in mind they've probably got some sort of support from the surface or the upper air. There's no question about that. And at the end of the run there, about noon, still going on there in East Texas. So let's look at the upper level. Okay, let me get this centered. Okay, for right now, this is how things look. You can see a couple of waves. This is heights and vorticity. This is up at about 18,000 feet. The orange shades are very high cyclonic vorticity. So that's basically a measure of shear. Let me see if I can draw that out. Let's see. How do I get a blank screen? I guess I can't. I'll bring up WordPad. Okay, yeah, there we go. So, vorticity. There's two components to vorticity. One is shear, and what I want you to do is to picture a propeller laying sideways in this stream here. So there's a propeller right there. So is the propeller going to rotate? Winds are kind of weak up on this side, and then down to the south, winds are even stronger. So sure, yeah, that propeller is going to start rotating. So that's kind of a cyclonic rotation. Now, another way we can get vorticity is through curvature. So let me redraw this one more time. Let's say the winds are like that, and our propeller is in the stream. Is it going to rotate? Yes. It's going to rotate and look like that. So that's kind of a cyclonic turning going on right there. So shear and sorry, let me draw that a little closer. Okay, so shear and curvature. Those are the two components of vorticity, and that's all it's showing there. It's nothing too complicated. That's one problem with a lot of meteorology books. They overcomplicate stuff, and there's a reason for that, but the fundamentals are really not too hard to follow. Where's my chart? There it is right there. Okay, so what this is telling us is right in this area here, northwest Oklahoma, central Kansas, we have lots of orange. That little propeller sitting in that stream, I'm going to put a dot for where it is getting either some good shear or some good curvature. Which one is it? Okay, well, here's one way to tell. See this lobe right here that's kind of parallel to the upper level flow? That's almost always a shear feature. So what's happening is we have that little propeller, say it's sitting right there over the UP of Michigan. We've probably got some very strong flow aloft right in that area and some very weak flow on the other side like that. So our propeller gets some very good spin in there. So drawing out the correct locations, it's going to look kind of like that. And so that means that right here we have very fast flow. So that's identifying some very potent jet stream energy from about north of Duluth through Green Bay all the way down to around London, Ontario, and out towards Albany. Okay, so you can kind of see what the appearance of those channel lobes look like. We call those channels. So the channel lobes, those are basically shear vorticity areas. Now the opposite is an advection lobe, and that's these things right here. And you can see they kind of cross the contours. So what's happening right here is probably more related to curvature. So basically our propeller sitting in that stream right there is being acted on by the curvature of the flow. So that's the main thing, giving it a little bit of spin. Okay, so there's one lobe right there, and yeah, these are short waves. That pretty much nails exactly where they are. So one over Texas, and that produced a little bit of thunderstorm activity in that area. And then out to the west, that's probably going to produce a little bit of thunderstorm activity later on too. The main areas of lift tend to be not within the vorticity areas, but out ahead of them. Let me redo that one more time. Yeah, so right there, lift being indicated, and right here, lift being indicated. And then down behind them, sinking motion. Behind this one, sinking motion. So these are kind of like couplets of up and down motion associated with a shortwave, which is in between. Okay, so that's pretty easy to follow. All these advection lobes work the same way. There's one right here, lift, and subsidence. So that's what's going on in that flow right there. It gets a little more complicated with these shear features, and we could probably go over that some other time. But on the west coast, yeah, there's another advection lobe coming on shore. So maybe conditions going downhill in northern California. Okay, why do we get upward motion? So I was telling you that we have a shortwave right there, upward motion in that area. Well, what's happening here is to keep the flow in balance, the atmosphere has to produce upward motion. Anywhere we have a region that's where vorticity is increasing with time, the atmosphere has to respond to that with upward motion to keep things in balance. Now, that doesn't always happen. Sometimes things remain out of balance, and these are basically assumptions here. And this doesn't always work. These are just guidelines, because what you need for this to actually represent upward motion, this vorticity actually has to increase with height. And normally we just assume that it does. Okay. So also it assumes that you don't have cold air advection beneath, offsetting the upward motion. So there's all kinds of little assumptions there, and this just basically gives us a starting point for diagnosing vertical motion, because you got to keep in mind the biggest thing that we look for in meteorology, the holy grail, is finding vertical motion. That's the hardest thing to diagnose, because you can't just take an anemometer and hold it sideways. That doesn't work. One problem is that the vertical motions in an environment like what you see over the Dakotas, Minnesota, we're talking velocities of only maybe 1 centimeter per second. That's very, very slow compared to the horizontal speed of the wind. The wind blows very quickly. We're talking tens of feet per second, and then the upward motion is it's literally like this. So there's no way of measuring that. So what we have to do is kind of use the large-scale picture and the pressure and height field, and that gives us some ideas for where we may find that upward motion. So it's that's a very tricky thing, and as I said, it doesn't always work. And if you try to directly solve this with models, you can do that. And let me bring that up here. Yeah, see this over here on the left. See, what I'm showing you right now is heights and vorticity, but there's also heights and vertical velocity. So this is where we directly solve the upward motion. And you can see that the fields they tend to be very noisy. Let me bring this up to tonight's time. So yeah, we are picking out a little bit of upward motion in that area, but we're also picking it up here, 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 here. So a lot of times in very active weather systems out there, see up there in Quebec, see what's going on here, you tend to get very noisy patterns, and it gets very hard to resolve the vertical motion. So the vorticity products do tend to help us out with that. Okay, on to the forecast. Let me look at the graph here. Sometimes I look at this and try to figure out if people have dropped off and went to some other channel when it gets too technical. And yeah, the graph, hang on a second. Give me just a second. Okay. Yeah, that's our graph of activity, and I can see that we've kept our viewers. We lost a few at about 8:15. I guess there was something going on with the stream, a drop-off. But yeah, I appreciate it. I'm glad you guys have hung in there. I guess my discussions are not boring you guys too much. Let me take another look at chat here. I'm just going to skim this very quickly. I've had a few people tell me that reading the chat kind of goes on too long, but I'll try to mention a few things where I can. Here's Johnny, here's Tim. Thank you, Willie. David Holcomb, if anybody has experience with software development using Nexrad, please hit up my channel. So yeah, head to David Holcomb's channel if you want to help with that. Burl H likes the drone view. Yeah, I love it. You saw that picture over the lake. I mean, that was so beautiful. Has lab started? Oh, I'm pretty far back there. Electric Dog right there near Chicago has got 80 degrees with a dry 49 dew point. And sorry, Michelle Curlin, you can. Yeah, if you can't catch the live stream, you guys can always just catch the replay. It posts about 15 minutes after we end the webcast. All right, Uncle minus 612 in Antarctica. Sue M. Reed Timmer is heading to Montana and North Dakota for chasing. And yeah, I'm going to be forecasting for a chase team tomorrow. And unfortunately, I can't really divulge who it is exactly, but if I don't have anything better to do, what I'm going to do is turn on the stream sometime tomorrow afternoon and let you see some of the hand analyses. So keep an eye on the channel, and maybe you can catch that live when it happens. Justin Pulliam, appreciate the comments. Shirley Keast, Electrodog seeing some buffering earlier. Yeah, this is the tool I look at to find buffering. I read this dropped frames, and earlier we had 2049 drop frames. Divide that by 24 to get number of seconds. So we lost about 100 seconds. That's about a minute and a half. So I apologize for that, but I think it's stable now. The many perils and tribulations with CenturyLink. Okay. Catching up on chat, and I'm going to have to read through these very quickly. Okay, thank you, Bill K. Bill K. Tornado count. As of the May 24th, 366 tornadoes. Actual 66. That's it. Yeah, what a slow season. Fire departments in the Woodlands, Conroe area of Texas. That's north of Houston. Very busy last night. Why is that? Is that from lightning strikes? Or is that from the wind kicking up fires out of control? It's got to be one or the other. 106 degrees in Tucson. Thank you, Rat. Feels like 95. And yeah, I lived in Tucson for a while. We had those evaporative coolers sitting on the roof, and those are literally a big blower with panels of straw. It's packed in there. This is what's in the central air unit, and it's got a pipe with water, and it pumps water into the straw, and it blows the air through. And you get that evaporative cooling going on in that gadget there. So that's very common in most houses in Arizona, and they work really well. And my grandparents, they tried using one in Fort Worth just to cool the bedroom down, and it worked a little bit. But on a hot day, that's not going to really help much because of the humidity that we have. All right, let's see what else. Ryan Toomey is reporting monsoon season starts next week for the desert southwest. Okay, thank you for that, Ryan. Sounding in Hawaii. Okay, yeah, we'll do a quick sounding in Hawaii, just very quickly. Where are my soundings? Yeah, look at this. Look at my tabs here. See, this is what I deal with on the webcast. If somebody asks for a sounding in Hawaii, so I'm looking on the tabs to try to find the soundings, and I've got all these tabs, and I'm trying to figure out where it is. It's really chaos, but I know it's in the middle. Yeah, there it is, right there. Okay, so yeah, we'll take a quick look at Hawaii. Skew-t. We'll look at Lihu or Hilo. So there's Hilo right there. So you're not going to get one for Honolulu. You've got to go up north or down south. And this is what it looked like. Lots of very rich tropical air all the way up to about 8,000 feet. And the big mountains, those extend up to about 12 to 13,000 feet. That's going to be right about here. Hey, I can draw the mountain. We'll just put that on there. Okay. So these are... I can't remember the names of the mountain peaks. There's two very tall volcanoes on the Big Island, and I'm sure somebody on here can name them. They're about the same height, and they come up to right about to that level. So we can see the temperature up at that level is about 5 Celsius. It's about 41 degrees. Very cool. And then down near the sea level area, it's about 70. And we can see a very strong inversion. See that right there? What's likely happening here, especially since it's dry above that inversion, we've probably got downward motion, subsidence. And that tends to warm that segment right there, you can see very warm temperatures in that part of the sounding. And this is very much like a cap. See that? It's like a loaded gun. Very classic. All we would need is a little bit more moisture, and we would easily have supercells, and it has happened. Let's lift that just with 80 degrees. I got to do this very carefully because I'm doing this with a mouse. Okay, LCL, about 4,000 feet, and then we lift. Wow, look at that. There's definitely some cape there. All of this is the cape. That's going to be over 1,000. And then we've got capping. Wow, geez. Thanks for that. Electric Dog, I think you've brought us on to something. Maybe storm chasing in Hawaii. And the atmosphere is definitely sheared. See the winds? 70 knots out of the west at jet stream level and down near the surface easterly at 10 to 15. That's some very good bulk shear. So we've got a lot of things going here for severe weather. The only thing is, I don't know if we can break that cap. Wow, it's very impressive. Let's check out the other one real quick. Lihu, which is up in the northwest. Come on. All right, there it is. Very similar, yeah. Another loaded gun sounding. Okay, well, that's another thing that maybe you guys might want to check out. Maybe look at the forecast discussions from Hawaii and see if anything's going on there. Okay. All right, forecast. We'll try to get on. Stumbling along here. All right. We did the short term for Texas. Let's go up and look at the big picture with the NEM and see what's going to happen over the next few days. And let's look at the upper level patterns. Okay, so what do we have here? Got a big ridge in the Great Plains. That is the biggest thing that jumps out when I pull up this chart. So a very large ridge. There's a broad trough on the east coast, maybe a long wave right there, and another long wave off the west coast. So Texas, Oklahoma, Kansas, the Midwest, all under northwesterly flow. So any storms that go up in that area, they should have kind of a southward drift. The storms in Texas, I think those were moving to the east. I didn't get a good look at them, but the steering flow looks like it's out of the northwest. So what's going to happen overnight? Let's see. Okay, the ridge kind of builds northward. And, oh, hang on, we're looking at vertical velocity. Let me switch back. Back to vorticity. And, yeah, see that right there? That's that short wave moving into southern Oklahoma. And then by midnight, 3 a.m., 6 a.m., you can see it moving across North Texas. So very likely that's going to be the cause of those thunderstorm activity, that thunderstorm activity there in the Lake Texoma area. As the day goes on, looks like we come under the influence of that ridging there in Texas. And another thing that you're going to want to look for is height fall, or height rises and height falls. And the way we do that, we look at the contours. We bring up the chart, and we're going to look at Dallas just, you know, as a guinea pig. And what kind of lines do we have near there? This is 18Z. This is about noon. Okay, so we got a 585 just to the northwest or northeast. We have a 588 to the southwest. 585, 588. So now I'm going to skip this 12 hours forward to midnight. And Dallas is right there. What has changed? There's 585, there's 588. Not much change. It's still right in the middle of those contours, but we've noticed that the winds have kind of come around from this to this. So a little bit more northerly. So not really much of a change tomorrow. It's going to be kind of that probably indicates kind of a stagnant day. But a good example of a big change. Let me pick a different place. I'm just looking around on the chart for some ideas. Yeah, let's look at Jacksonville, Florida. They're going to be located right there. So we start out 18Z. So we have a 582 to the north of Jacksonville, and very close to Jacksonville we have 585. So what happens 12 hours later? Ooh, looks like the heights have gone down. 579 to the north, 582. So we've had height falls. And that's very important. See, I'm showing you some things that you'll want to look at when you're analyzing the weather at your location. Height rises, height falls. A height fall like we see at Jacksonville, that's going to indicate that the column is becoming cooler. So if you've got a cap, that might indicate maybe a little bit of weakening of the cap. Also, it indicates that there's probably been some upward motion. Height rises are usually associated with downward motion and subsidence. Height falls are usually associated with upward motion, and you get that adiabatic cooling, and as a result, the heights drop. So it's a very straightforward relationship. So, yeah, especially in summer, that'll kind of give you an idea of what's going on. If you see height rises, you'll see the contours expanding over time, and that usually points to fair weather and a warming trend. All right, so for tomorrow, let's see what's going to happen. This is tomorrow morning, and then tomorrow evening. It looks like that area of short waves moves towards western Florida, Alabama, and Georgia, so things will probably be kind of unsettled in that area. If you have a flight out to Pensacola, Mobile, New Orleans, I would probably double check the weather, and maybe even Atlanta, right there on the edge. Things should be pretty good in the Great Plains. Looks pretty quiet. Up north, frontal system will keep things active in that region. And now the big awaited changes are out west. Look at that. The contours. If I bring this back to Wednesday, see right there? Oh, Tuesday. See how they're almost directly out of the west, and then we come up to Thursday, and they're like that. So we've got a lot of amplification of the long waves going on as we go into the last half of this week. So amplification of that big ridge across Canada, probably very warm in Calgary, Saskatoon around Thursday. And then we've got a big trough out east, and I've got a different product to show you. Yeah, here you go. This will give you some idea what's happening later this week. So these are the jet stream winds with the jet stream height contours. This is up at 30,000 feet, 300 millibars. And starting out, look out here in the Pacific. See that jet there? It looks very long and very straight. That's a zonal pattern. And what I find is these very long zonal patterns like that, like this, and like that, those tend to be kind of unstable. Not thermally unstable, but they're physically unstable. And typically what will happen is you'll get sudden amplification of the entire pattern. And indeed, that's kind of what happens. See how things are collapsing. So I'm trying to think of an analogy. Basically, the whole wind field is kind of crumpling up there. And it doesn't take much for that to happen. So now, very rapidly, we develop this vortex out there by Friday. This is an upper level low, and we end up with this big chunk of jet stream energy forming this big trough out in the Pacific. So that's going to rapidly change the weather. And yeah, look at this. Very strong trough coming into northern California. Probably some good rains there in Oregon, north of San Francisco up to Fort Bragg and Arcata and Red Bluff. That jet will be coming inland, and this time of year I wouldn't be surprised to see some severe weather in that area going Friday into Saturday. Then later in the week, that trough will be moving inland. Not much of an effect there in Texas, but northern plains should see some more severe weather. And this big trough, that's going to have an impact at the surface. Let's show you what that's going to be. this is the sea level pressure and thickness. Okay, so starting out, let me just draw the fronts. There's a cold front right there. There's a warm front. This is for about right now. This is the cold front that's going to be affecting our weather here just after the weekend. It's going to be a big change. So this is it in the very embryonic stage. And behind that cold front, look at these thickness lines, this red and blue. 1, 2, 3, 4, 5. That's pretty strong for this time of year. This is a lot of cold air lurking in the Aleutians and the Gulf of Alaska. So let me show you how this changes as we go into midweek. So now keep in mind that the upper level patterns, they're starting to amplify as that strong zonal jet stream starts to bend and become cyclonic. And let's see here. We'll fast forward to about, let's see, yeah, about to Friday. Now, the cold front is looking somewhat like that right there. So it's just off the coast of Washington. Very strong front coming inland. And 540 decameter, that's usually associated with snow. When we see that in the U.S., that's all the way down to about Comox. That's going to be northwest of Vancouver. And it is coming towards the west coast there. Some very cold air. So the cold front by Saturday should be looking like this, coming onshore. So I'm going to step this through. When we do the webcast on Saturday night, cold front's going to be about right here. It's going to be coming through the San Francisco, Sacramento, Reno area. And man, look at that packing of that gradient. See that right there, that thickness? That's some very cold air coming inland. So we're definitely going to be seeing the effects there on the west coast of that cold air coming inland, and possibly due to that strong gradient there, a good jet stream. I think there's going to be a chance for severe weather somewhere in here. That could be anywhere from Northern California up to Alberta. Just depends on where the moisture is, the low-level moisture. So we're looking at Saturday. Let's go up to Sunday when we do the webcast. I forgot, usually we're off Saturday. But anyway, for Sunday, when we usually do the webcast, okay, the cold front is starting to cross the Great Basin and Rockies. Now the thickness field, yeah, that does reflect it. See right there, there's 1 red line, 2 red lines, 3 red lines, 4 red lines, 5 red, and the 540 is coming into Seattle. So that's going to mean snow in the higher elevations in June. Very unusual weather. And also the pressure. So look at the black lines out in this area. Wyoming, Idaho, on Utah. Very strong pressure gradient. So that also indicates where the front is. I wonder if maybe Salt Lake City might get some thunderstorms around Sunday, Saturday or Sunday. They definitely can get some big ones in that area. Let me see what the timing would be for that. It really depends how much moisture they have. I guess that would be coming through maybe on Saturday night. So anyway, this cold front is working eastward pretty quickly. So by Monday, when we do the webcast, it's already punched out into the Dakotas. So let me see what the transition looks like between the two. Yeah, there it is right there. This is early Monday. And then it looks like that joins up with some Canadian air that just happens to be up there in Ontario. So this is the meeting of the minds of the two big cold air masses. There's one right here, and there's one up here. So they're coming together, joining forces, and that's going to push a cold front southward very quickly early next week. So by Tuesday when we do the webcast, now we've got this giant high across the Great Lakes area, cold front all the way down to the Gulf Coast, and look right here in Texas, there's an inverted trough in that area. And by inverted trough, I'm talking about this 1008 millibar line. I'm going to draw it. See how it kinks like that? There's some sort of trough right in this area here, and that's probably indicating that maybe there's a little bit of cyclone development, maybe some baroclinicity in that area. and possibly a bit of a warm front setup, so something like that. So might be looking at maybe a chance of severe weather possibly on Tuesday the 12th. But that's a big maybe. This system is going to be moving southward pretty quickly. I imagine it's going to be out in the Gulf waters by Wednesday. And let's see what happens later. Another cold push coming inland. See right here. So, man, we're really getting hammered with these blasts of cold air coming in. This is around the 15th. The Gulf starts to open up once again around that time, and then the next cold push comes southward. There it is right there. So we're going to see more thunderstorms. This is kind of the opposite of what we should be seeing when the Great Plains starts shutting down, because usually what we're looking at in late June, we've got the Bermuda High starting to build into the build into the central U.S. And let me show you an example of what that should look like. We just have to roll this back a little bit. Yeah, let me find a frame that is pretty characteristic. Let's see. Yeah, something like that there. Yeah, see this Bermuda High out here, and you can see how the lines extend into Florida, Georgia, South Carolina, and like that. That's typically what we see in late June. And that tends to shut down things in Texas. We get the upper level ridge start to build in. And it's just warm and sunny. But we've got a much different pattern coming up towards the 12th, 13th, 14th. Lots of action and some cold air coming down, moderating the temperature, so it should be kind of cool around the middle of June. And then we have this next boundary coming southward. All these boundaries and tail ends of fronts, these are many, many ingredients that help with thunderstorm development. So it may not be severe, it may not be supercells, but it will be thunderstorm activity, and I think there will be quite a bit of it. Okay, and that brings us to the end of the GFS. So yeah, when you get a chance, feel free to look at the GFS there on Pivotal Weather. And of course, you might want to pick up the European model. That's on eurowx.com. And I appreciate their granting us use of those products. I'm not going to bring that up tonight because we've covered quite enough by now. We're already like almost an hour and a half into the program. So we'll start wrapping it up about right here. Let me get caught up on chat, see how things are looking. See a few people dropped off about 10 minutes ago. Okay, a little discussion there about buffering. David Moore likes the discussion. I appreciate that. Sue M. likes the vorticity discussion. Yeah, for those of you that missed that, we were talking about vorticity. That was about 20 minutes ago, I think, 10 to 20 minutes ago. Electric Dog likes the class. Sue M. asks if it's reversed. It is reversed in the southern hemisphere. The Coriolis force, the sign of that changes over. So the when you're talking about shear, what's cyclonic, it would just be backwards. So that right there in the northern hemisphere, that would indicate anticyclonic vorticity. But in the southern hemisphere, do I have my... Yeah, okay, that's right. So yeah, in the southern hemisphere, that setup would be cyclonic. So yeah, good point there. Okay, Cthulhu, thanks for helping in there in chat. Mauna Kea up to 14,000 feet. Pyrocumulus. Yeah, there was some spectacular pyrocumulus with that volcanic eruption back around the 23rd. I was looking at that earlier. I might have to bring that up one of these nights. How does height falls end up changing the stability of the atmosphere? Keep in mind that the height falls are a response to things that are happening in the lower and middle troposphere there. So when you see a height fall, that's not indicating that the heights are falling. It's more indicating that something is changing the heights, and that's usually, if it's height falls, that's going to be lift, which means Adiabatic cooling, which means height falls. So how does that end up changing the stability of the atmosphere? Well, if you get cooling, that'll tend to, well, that gets into potential instability. That kind of depends on the moisture distribution, and that might be a show for another night there. But if we have very moist conditions in the lower atmosphere and very dry conditions aloft, you'll tend to get latent heat release in the lower atmosphere and none aloft, and that will steepen the lapse rates. So indeed, height falls with very moist conditions in the lower levels, that can steepen the lapse rates quite a bit and bring up the Cape. And of course, it's the opposite with height rises. That will tend to build your caps, and over time it will lessen the lapse rate there. Suim says, great webcast. I appreciate that. Ryan Toomey's great teaching. Thanks. What is my chat doing here? I was trying to read chat and it was just sitting there flickering. I'm not sure. Yeah, see what it's doing there? Okay. So, yeah, Electric Dog likes the discussions. David Moore, great webcast. I appreciate that. Ryan Toomey's, thanks for the discussion. Okay. Yeah, I appreciate that, guys. So we will go ahead and start closing things out. Wow, great show. Hope to see you guys tomorrow. Thanks for joining. Tomorrow's what, Tuesday? I guess we'll have some severe weather if I can get the camera set up, and if I have time, I will start the webcast sometime in the afternoon. I'll do kind of a special brief one and track anything that's going on. Anyway, thanks for watching, and we'll see you tomorrow. Take care.